Alright, before you watch this video, please try out the Check Your Understanding on your own. You know, we have a summative coming up Thursday, so just see where you're at and try it out. So, we're just going to jump right into it. And also I'm a little sick, so sorry for my voice and any coughing that I do during this video, but I should be fine to make this video. We gotta write f prime of x as a piecewise function. So we're given f of x, which is a piecewise function, and we're basically like writing f prime of x in the sense that when x is greater than 2, what's going to be the derivative? When x is equal to 2, what's going to be the derivative? If x plus 4 is less than 2, what's going to be the derivative? So we're gonna kind of graph it like, or kind of write it like that. So honestly, what I would do is just write out the derivative for each of these. So d of x, 1/2 x plus 5. Remember, derivative is just slope. So the slope of a line, the derivative of a line is just the slope, 1/2. And then we could take the derivative of 6, which is 0. Right, because if you think about, if you were to graph y equals 6, it's going to just be a flat line. So there's no slope, there's no derivative, or the derivative is 0. And then d of dx, x plus 4. The d of dx just means I'm taking the derivative of that like kind of equation, kind of function. So the derivative of x plus 4, the slope is 1, so that's going to be my answer. Sorry about that. I have a really cheap knockoff Apple Pencil, so it gets kind of glitchy sometimes. So those are the derivatives at all the certain points. So, or like for example, this is the derivative when x is less than 2 or greater than 2. This is the derivative when x is equal to 2 and then less than 2. So, excuse me. We would just write it as f prime of x equals so I'm going to say 1/2 when x is, what is it greater? I don't know why I blanked. X is greater than 2. I'm going to save the middle one. I'm going to say x plus 4, right? The derivative is 1. So x is less than 2. So now for f prime, what about when x is equal to 2, right? Should it be 0? Now, I'm going to hold off on that, and I'm going to actually go to B, determine if f is differentiable at x equals 2. Now, if you want to determine if a function is differentiable at a point, if you're given a piecewise like this, make sure it's continuous, right? If it's not continuous, it can't be differentiable. So check if it's continuous. So easy way to check is, well, as a limit as x approaches 2 from the left of f of x equal to, and this is like a question mark, just letting the grader know that, hey, I'm checking, I'm not saying they're necessarily equal, to plus f of x. So I'm taking the limit, and you can fast forward this if you like. I'm just making sure my notation's good. So from the left, it's x plus 4. And I think you need parentheses, I'm pretty sure. I don't think parentheses would hurt. And then we're going to say 1/2 x plus 5. And then we just plug in the 2. So 2 plus 4. Is that equal to 1/2 2 plus 5? And it sure is. I'm going to make sure I'm adding the question marks. So that condition is true. Now let's just make sure. Now is the limit as x approaches 2 f of x equal to f of 2. F of 2 is 6, and then our limit as x approaches 2 is 6. So that's good too. So it's for sure continuous, but that doesn't mean it's differentiable. Because now you got to look at, well, what about the graph, right? So, excuse me. Or sorry, what about the derivative graph, right? Or the derivative function. So if I were to graph this actually, if I were to graph this original one, I get 1/2, or x plus 4, so I would get something like this. At x of 2, it's equal to 6. And then after that, it's going to be 1/2 x plus 5. So I would get something like that, essentially. And you could tell at x equals 2, that's a sharp point, right? You can't draw one tangent line. I could draw a tangent line like this. I could kind of draw a tangent line like that. Like, there's not one set derivative. For something like a quadratic, And I'll just do that here, right? The idea is that, yeah, at this point, there's only one possible tangent line. If you zoom into the curve, if I try to do something like this, it wouldn't be a tangent line. It would pierce through another point or something like that. But for a sharp point, you can't have that. And that's just how you can kind of visually tell. Now, if you want to like formally prove that, what you would do is, it's kind of the same idea. It's the limit as x approaches 2 from the right, f prime of x equal to the limit as x approaches 2 negative f f prime of x. Yeah, I don't know why I started there. And then you just get, so from the left, it would just equal, or sorry, from the right, it would equal 1/2, which isn't equal to from the left, which is 1. So, so I would say, not differentiable. The derivatives, differentiable, I would say maybe something like, sorry, I was kind of speaking quiet. I don't know, actually. I have no idea how this, I don't have a mic or anything. I would say, though, not differentiable because derivative of f of x differs from right of 2 and left of 2. So the derivative is different on each side is what I'm saying, even though it's continuous. So what does that mean then? Well, if we come back to A, is there really a derivative at f prime of x equals 2? Like when x is equal to 2, if we say 0, that means that it is differentiable. Like the derivative of f of x at 2 would equal 0, but we just said it's not. So I would say, in my opinion, I would say undefined. It's undefined at x equals 2. Because it's not differentiable at x equals 2. Use the definition of a derivative, so to find f prime of x of f of x. So this is kind of straightforward. It's just algebra heavy. F prime of x is just the limit as h. Now you could do kind of any limit definition. I'm doing the right difference quotient, which is kind of the most famous, where we have 2 root x plus h minus 2 root x over h. All right, so now we just gotta manipulate this, and I think the first thing that jumps out to me is, let's do multiply by conjugate. So the whole point of multiply by conjugate is we can kind of use difference of squares like so. 2 root x plus h minus 2 root x. Excuse me. Oh, and we're doing plus, right? Because we got to multiply both the top and bottom by the conjugate. So limit as h, always have this limit as h approaches 0. It's good notation. So 2x plus h minus 2x. And I'm just exploiting, difference of squares, right? So if I multiply this and this, it's 4x plus h, right? You got to square that kind of term over h, and then we'll do 2 root x plus h. We can kind of just leave it like this, and you're going to see why, right? And then, by the way, if you were to, plug in 0, you'd get 0 over 0. So the h has to cancel out, which is why I'm not multiplying it out, right? Because I know eventually that h should cancel out. So I get 4x plus 4h minus 4x. Great, the x's cancel out. Cool. Okay, limit as h approaches 0. We have 4h over h, 2 root x plus h plus 2 root x. H is dropped, finally. And now, you could just plug in the 0. You have 4 over, so 2 root x plus 0 plus 2 root x. And then, if you bring this over here, I'm going to draw a little arrow to just let my grader know that, hey, I'm moving over here. 4 over 2 is just 2. So I get, wait, I shouldn't do it like that. 2 root x, so x plus 0 is just x, right? So 2 root x plus 2 root x, that's 4 root x. Which it will just end up equaling 1 over root x. Awesome. And then use f prime of x to determine at what point the tangent line to f of x or whatever has a slope of 2. So I'm just saying, hey, at what x value, or what point, and I'm going to use the x value for that, is the slope going to equal 2? So when is it going to equal 2? And then I get root x better equal 1/2, or x is equal to 1/4. I'm looking for the point, though. So then, what I'm going to do is I'm going to say f of x, or f of 1/4, is equal to 1 over 1/4. So we get f, which is going to equal, I could just say 1 over 1/2, which is equal to 2. Yeah, it's equal to 2, just making sure I'm not rushing that. So we get 1/4, 2. And then write the equation of the tangent line at x equals 9. Well, so if you want to write the equation of any line, you got to have y minus, like a point. So my minus y1 equals m x minus x1. So this is point slope form. I like this the most because I know my x, I don't know what you would call that, x naught maybe, I don't know. My x that I'm using for this is going to equal 9. And then my y prime is going to equal, f of 9, right? So if you're kind of confused about what I'm doing, this is point slope form. And then you could, I won't go too much in depth to it. You can watch a video if you need a refresher on that. It's just a way to write equation. You could also do y minus mx equals mx plus b. I don't like this as much because then you got to find the y-intercept. But that way also works. This way is just easier on a pinch. And then these are kind of your y and x variables. And then you got to find the slope. So to find the slope, I'll just say f prime of 9. F prime of 9 is equal to, it's equal to 1 over root 9, which is going to equal 1/3. Cool. So now f of 9 is going to equal 2 root, oh my god, wait. I just realized, hopefully you caught my mistake. We're using the wrong function. F of 1/4 is 2 root x. So in here, I would get 2 root 1/4, which should equal 2 times 1/2, which is equal to 1. Excuse me, I'm sorry about that. I'll be better tomorrow, I promise. F of 9 is going to equal 2 root 9, which is equal to 2 times 3, which is going to equal 6. So then I could just write simply y minus 6 equals 1/3 x minus 9. So, I should probably explain what this result really means. If I were to have my graph, so it's 2 root x, right? At x equals 9, the equation of that tangent line just equals this. Like, this is the equation of that line. And I'm gonna actually head over to this is like, I do kind of like, I do like different, like I made a new copy, so I'm gonna head over to this one. The reason being, and you can see also, whatever. This is what I'm gonna be submitting. I wanted to work on this last page on my own, just so I'm not repeating work. The position, and I'm gonna kind of, like, this is me seeing this blind. I haven't seen this problem yet, so I'm gonna kind of go through my thinking. The position of a continuously moving object at time t is given by a twice differentiable function. I have no idea what that means, and that's okay. I'll figure it out. Where s of t is measured in meters and t is measured in seconds, and then we have some values here. So this is continuously moving. That means what does it mean? It means continuous function. So find the average velocity. So if you're finding the average velocity, you're gonna really be doing so. I'll say v average is gonna equal f of 1.6 minus f of 1 over 1.6 minus 1. And what I'm really doing is I'm finding the secant line. So I don't know what my function is. Maybe it's something like, I don't know, this. But if I have 1.6 right here and 1, I'm finding the slope of that secant. That's what I'm doing. So, which makes sense. I have y minus y1 over x minus x1, which is our slope equation. F of 1.6 is 0.399. Oh my god. Minus f of 1, which is negative 2.4 over 0.6, which is going to end up equaling, okay, so I'm just going to do, it's going to end up equaling 2.8799 over 0.6, and then we're looking at meters per second here, yup. I don't know how I'm going to simplify that. I'm just going to hope my teacher takes that. Use the symmetric difference quotient to estimate the instantaneous velocity at 1.5 seconds. So here's how I would do that. I would kind of do, I would kind of say, so the symmetric difference quotient. So I'll say V estimate is going to equal F of 1.5 plus H minus F of 1.5 minus H over 2H. That's a symmetric difference quotient. And I'm going to use, over 2H. And then if you're confused about that, you can ask me in the comments. I'll kind of clarify what this is. It's just another way to get the secant line where you're kind of saying the change in x is 2H, and then you're going kind of plus H and then minus H for a function. I can explain it more if you need to. That's kind of a rough explanation. But regardless, I'm doing it like for 1.5, so I could see in between I have 1.4 and 1.6, and basically I'm just looking at the rest of these. So this is in between 1.5, and that H, right, is 0.1, because I'm going 1.5 plus 0.1 to get 1.6, and then 1.5 minus 0.1 to get 1.4, which is perfect for this thing. So I'm going to say V estimate is going to say F of 1.6 minus F of 1.4 over 2 times 0.1. Which is probably just 0.2. So V estimate is going to equal F of 1.6 is 0.399 minus negative 0.744 over 0.2. So if I were to just do this really quickly, I would get 0.744 over, or plus, because I'm adding them, 0.399. So I get 3. You could use a calc. Actually, I don't think you can. Never mind. So that's 4. That's 1. That's 1. I don't know if I did that right. I really hope I did. If you guys have better arithmetic than me, I'm sure this will be no problem. Excuse me. Is the average or instantaneous velocity of the slope a secant line? It's going to be a secant line. Or, sorry, the average is a secant line. Provide a reason. So, I guess if I had a function f of x. So, I'm just going to kind of draw a random function. And I'll say right here. So it's going to kind of, wait, I should do it better. I don't know how to draw these things. There we go. That's better. So the way I would kind of explain this is like average is secant line. Secant line. And I'll say, like, to find the average velocity. And by the way, this is notation. I just remembered. Don't say F, say S. I just remembered that. excuse me, of s is f of t the equation is s of t plus h minus s of t over h, which is the same as the slope of a secant line piercing, and I'll say like t s of t and t plus h s of t plus h. A rough explanation. I don't know. I don't know how else I would explain it to otherwise like this. I think this would probably make the most sense. So maybe I'll even say t, my pen, I swear, t plus h, and then s of t of plus h, and then s of t. Find the minimum number of times the object had position 1 meter. This is IVT, so the way I would probably do this is I would say like, hey, how many times is it? Like, how many times is 1 in between like these kind of values? And it's really only once. It's really only like here, right? That's the only time 1 is in between one of those things, or one of those kind of like s of t's, right? It's the only time 1 is in between any other two positions. So I'll say 1 time, at least once, I'll say. So I'll say s of 1.6 is going to equal 0.399. And s of 1.8 is going to equal 1.825. And then I'll say s of 1.6 is less than 1, which is greater, or yeah, less than 1, which is greater than, and then s of 1.8 is greater than 1. Thus, there exists a t where 1.6, I'll say it like this, equal and s of t equals 1. I'll say it like that. There, cool. This is IVT, intermediate value theorem. So that's it. Thank you.